Okay, so we're doing 2 lessons in this video. We're talking about similar transformations and their corresponding parts. So we talked about some of this today. Just want to reiterate some things. So first of all, congruent. We already know that that means things are the same shape and the same size. And specifically, if they're the same shape, all the angles are congruent. That's what makes it the same shape specifically. The same size becomes because all of the sides are also going to be congruent. And then we know that we write congruent as this little equal sign with it's called a tilde, but that little squiggle on the top. The transformations that we already know about that create congruency are translations, rotations, and reflections. We've already learned about the 3 of those. So different today, we're going to talk about similarity. So similarity is when figures have the same shape. Okay, so it's not specific that they have the same size, but they do still have the same shape. So in the same way, it means that all the angles need to be congruent. That's why we said today that angle is an example of this, because that means all the angles are congruent. But it also means that the sides are going to be proportional, which is another thing that we figured out as we were talking about dilations. So that's an important part of similarity. Notice that in similarity, we write that with just the tilde. So if you're going to say 2 shapes are similar to each other, you may say like triangle ABC is similar to triangle EFG. If I could spell EFG. And so you write that with just that little like tilde in the middle. And the transformation we have specifically for similarity is dilation. That's where we talked about those sides being proportional today. All right, so with similarity, we also talk about the scale factor, specifically when we talk about dilation. So up here in the top, I want you to note that the coordinate notation for a dilation is going to be this xy to kxky, where k is the scale factor, and the center of dilation, unless otherwise stated, is always going to be the origin. And then the other thing that I want you to note here, so I'll zoom in for you just to make it a little bit easier, is what the scale factor represents. So if we're looking at numbers that are between 0 and 1, that's going to give us a reduction in size. It's going to make the resulting image smaller than its pre-image. If k is greater than 1, that's going to cause what we call an enlargement. So it's going to make the image larger than the original pre-image. They don't say if k is 1, because if you think about that, if k equals 1, you're just going to come up with the exact same figure that you had before. All right, so we want to talk about are we going to be able to determine if 2 figures are similar using transformation? So we're looking, is what is occurring an example of a dilation? So they've gone ahead and mapped for us some similar points. So they've mapped x to y, x to, I cannot say letters, r to x, s to y, and t to z. So we want to determine, is the same multiplier occurring on all of these corresponding coordinates, and we're talking about for x and for y. And I hope that you see that they do. So this is xy is going to become 3x and 3y. So yes, these 2 are going to be similar. So we could write that to say, yes, triangle RST is similar to triangle XYZ. And this is going to be by a scale factor. Sorry, I know I'm writing over what I had before. A scale factor of 3, because it's going to get 3 times larger. All right, so we could do that same idea for another problem, for any of these problems really, to determine if they're similar. But I also want to show you another method, because this may make more sense to you or may even be easier. So question D up here is asking, are the corresponding angles congruent? And in this figure, it's really easy to see that yes, they are congruent. We have 90-degree angles in both of the rectangles, EFGH and ABCD. So yes, these are going to be congruent, which is one of the requirements, right? Similarity says angles are congruent. Then we need to check that the ratios of corresponding side lengths are equal. So A to B, notice that I'm counting by 4s here, or sorry, by 2s. So A to B is going to be 8 units long. while E to F, 2, 4, 6, 8, 10, 12, 14, is going to be 14 units long. And if I simplify that ratio, that's going to give me 4 to 7. All right, I would like for you to pause the video and see if you can fill out the other ratios here. Okay, so when I do that, I notice that these do not all simplify to be the same proportion, which means that these are not going to be similar because the corresponding parts are not proportional. All right, so that would be our answer there. Let me show you one more way to determine that. All right, the other way I think to determine that is really to think about how we did dilations today. So remember, if we dilate, we're dilating along this line, which connects to the center. So for example, if I think about how to get from like our center to A and our center to E, those are along the same line. However, if I try to draw this same line through D and H, notice that D and H are not even on the same line. And if I try to draw a line through D and H, it is going to change my center, which I can't have things dilating using different centers. So because of that, that's another way to determine pretty automatically that these two are not going to be similar. All right, so just to make sure we understand corresponding parts of similarity, let's try these questions 5 and 6 in the middle. You can go ahead and pause the video and read the question. What they're asking me is to determine what the similarity factor is and then to write coordinate notation for that. So I notice, first of all, I just want to check that they've given me corresponding parts. And indeed, based on how they have these written, QR is going to correspond with MN. If you think about if I'm going from PQR to MN, this is going to be getting larger. So in my mind, I just think about how can I set up a ratio between these two so that the scale factor I get is greater than 1. And to me, the way to do that would be to do 9 over 6, which simplifies to 3 over 2. Right, you should agree that that value is bigger than 1. So to write my transformation then, in coordinate notation, that means I'm going to do xy and take that to be 3 over 2x and 3 over 2y. All right, and then question 6, if you want to pause and read that one for a minute, we're trying to figure out what the error is in this statement. All right, and again, just know that corresponding parts go together the same way that they did for congruency. So if I look at the corresponding parts, DE does correspond to UV. All right, that's true. And then VW does correspond to EF. Now, I don't know if you noticed this, but the problem is they've switched the order in which they're naming these corresponding parts. All right, if you're going to start with the pre-image over the image, then you need to have that same setup on the other side. Right, notice that DE and EF, since they come from the same triangle, EF should be on the top here, right? Okay, the last skill for today, and this is one I think you're probably going to want to work on for a little while in class tomorrow, but we can talk about that, is sequences of transformations. So we're talking about how to map this pre-image, JKL, onto the triangle that they've given us, PQR. So we know which vertices are supposed to correspond to one another, and we have all of the transformations at our disposal. So when I look at this, the first thing I think is I want to make them the same size. So I want to actually take care of any dilation that needs to occur first. And to me, the easiest thing to do is maybe to pick two corresponding lengths and determine how what the scale factor is between those two. So I see J to L is 3. And if I count P to R, that's 9. So that means that PR is 3 times larger, so that's going to be my scale factor there. So the first thing I'm going to do is write out that I've got a dilation here by a scale factor of 3. And then just to help myself, I'm going to actually perform that dilation. So I, again, think about drawing those lines like we did today. So from the center, J is 1 away vertically. So then my new point is going to be 3 away vertically. All right, so this is going to be my new J prime. And then K, remember we're dilating along this line from the center to K, so that's 1, kind of up 2 over 1. I need to perform that 3 times. So that's up 2 over 1, up 2 over 1, up 2 over 1. This is going to give me my new K location. And then L, I see, is up 1, so I'm looking from the center to L. That's up 1 over 3. So I'm going to perform that 3 times. Up 1 over 3, that's 1. Up 1 over 3 is 2. Up 1 over 3 is 3. So it's going to put my new L out here. All right, so that's my next version of my triangle. So now I need to figure out, now that they're the same size, to me it's a little bit easier to start getting them into the same place. So the next thing that I see is that we probably need to reflect this across the y-axis. All right, which is this coordinate notation I've written at the bottom. XY becomes negative XY. So if I go ahead and map out that new triangle, it's going to get me out over to -9. So now I look like this. All right, so I'm starting to kind of fix the orientation a little bit. And the last thing I see is that this is going to need to rotate so that it's in the right spot. And to me, this is a rotation. I'm rotating 1 quadrant, which we remember is 90 degrees. And if I draw that out, I'm just drawing that arrow to show myself that that is actually a clockwise rotation. So my third here is a rotation clockwise of 90 degrees. And if we map out the coordinates for that, remember what we've done before, what you all said was pretty easy, was to pick 2 corresponding points. So if I pick this point right here, that's going to be -9, 3. And when I rotate that, it becomes 3, 9, because that's going to move up here. So if you think about how that's changing, that should give me the rule y negative x. Now, I could be very wrong in thinking that this is where you're going to want to spend most of your time practicing, but I think this just kind of takes a little time to let your mind wrap around and make sense of. So unless you tell me differently, I think this is where we're probably going to start and spend a good chunk of time tomorrow. So make sure you have notes taken, and we will work on these things together.